Lesson 3.4. Our objective is to solve and graph multi-step inequalities. A compound inequality is two simple inequalities joined by and, or. Okay, with this lesson, we're going to solve and graph compound inequalities. A compound inequality is just two simple inequalities joined by the word and or. Okay, now if you have my notes sitting in front of you, you can see examples of what the graph should look like after you've solved the inequalities. For our first example, we're just going to simply solve the interval notation that we have. We're just going to solve. These have already been solved for us. We're just going to draw the graph. Excuse me. We're going to draw the graph, and then on our next example, we'll go ahead and get started solving it. So what I have here, I have x less than or equal to 8 and greater than or equal to 3. So if I wanted to graph this, I'm graphing it on the same number line. I see that I have a 3. Oh, excuse me, that is not a very good looking arrow. I see that I have a 3 and I also have an 8. So those are the two numbers that I'm going to want to put on my graph, 3 and 8. Okay, I know that I have to circle them and shade them in, but now that you already know. Now if I look at this section, I have x. I want x's that are less than or equal to 8. On the number line, on my number line, x's that are less than or equal to 8 are going to be to the left of 8. That you already know. And then for the other one, the other side, I have x's that are greater than or equal to 3. So on the number line, anything greater than 3 will be to the right of 3. So when I complete my graph, I have all real numbers that are between 3 and 8, including 3 and 8. So this is what my graph would look like. And I will call this one an and inequality. The next one is an or inequality, and you see plain as day it has the word or in it. So when I get ready to graph it, I just graph them both, one at a time. I have the numbers -5 and -2. Have to put my -5. Have to put my -2. Make sure that you are putting your numbers in the correct order, and make sure you know that -5 is smaller than -2, so make sure that you're putting it in the correct order. I have some students that will forget about the negative signs and flip them around, so be careful of that. Okay, put my circle around, and I see that it says x less than -5, so I know I don't have to shade anything in. And then the other one says x greater than -2. So I want x's that are less than -5. Well, on my number line, x's that are less than -5, I know will be to the left of -5. So I will shade this portion. The other side says are x's that are greater than -2. Well, on my number line, anything greater than -2, I know will be to the right of -2. So what my final graph would look like, this gives me all x's that are less than -5 on this side, and this section gives me all x's that are greater than -2. And this is what my final graph would look like. Okay, so now let's go ahead and solve a few of them. I'm going to move this so we can see our next example. This time we're going to actually solve and graph. We're going to do two together, and then I'll let you do two on your own. All of these are and inequalities. I would call all of these an and inequality. And we have a basic idea of what the graph should look like. Well, when I look at this thing, I see that I have three sections. I have one on the left, something in the middle, and something on the right. Well, if I were to cover this up, I'm going to show you this real quick. If I were to cover this side up, okay, this just looks like the inequalities we've been solving in the past. Okay, and if I were to cover this side, it's really the same thing. It's just that the inequality is on the left side as opposed to being on the right side. But it's the same thing. Well, when I get ready to solve, what I'm going to do, I'm going to use the transformations that I would use when I was solving simple inequalities, except I'm going to do it to all three sections. On this first one, I'm going to keep it divided in sections so you'll see what I'm talking about. I know my goal is simply to isolate my variable. I still have the same goal. And I see if I'm going to do that, I need to get rid of this -1 and I need to get rid of that -2. Once again, I use the same transformations as if I were solving a regular inequality or if I were solving equations. If I want to get rid of -1, I would +1. However, I'm going to +1 to all three sides. Okay? And then I'll bring down what I have left. -4 plus 1, excuse me, -5 plus 1 leaves me with -4. In the middle, ones cancel out, and I'm left with -2. Bring down my inequality symbol, and over on the right, I have 9 plus 1, which is 10. Oh, forgot my X there. So now I'm left with, this is the inequality that I'm left with. Next thing that I know I need to get rid of in order to isolate my variable is a -2. So that means I'm going to divide all three sections by -2. I'm dividing. -4 divided by -2 is a +2. Remember, when you're dividing by a negative, you have to reverse your symbol. Don't forget that rule. The middle section, the -2's cancel out. I'll bring down my X. And then on the right, I'm dividing 10 divided by a -2. Once again, I'm dividing by a negative, so I have to reverse my symbol. And 10 divided by -2 leaves me with a -5. So here's my solution in interval notation. I have x is greater than or equal to -5 and x is less than 2. So now I want to graph it. Now remember, you have to put the smaller number on the left. Remember, we're putting this is a number line, so your numbers do have to be in order. So -5 is smaller than 2. So I'll put my -5 and I'll put my 2. Well, for -5, I see that -5 is included in the solution, so I'll have to shade it in. But 2, it just says less than 2, so I don't need to shade that in. So now when I read this thing, I want x's that are greater than, I'm reading this side, I'm reading the right. I have x's that are greater than or equal to -5. Everything greater than -5 on the number line will be to the right. And when I read the left side, I want x's that are less than 2. Everything less than 2 on the number line would be to the left. So I end up with everything in between. I have all real numbers that are between -5 and 2, including -5. Okay? I think that's a fairly simple process. Let's look at this next one together. Now I have -13 less than or equal to 7x plus 1 less than or equal to 50. Now remember, our goal is always the same. We want to isolate our variable, so we want to get this x by itself. So that means that I need to get rid of that 1, and I need to get rid of that 7. And I'll get rid of the 1 first. I'll do that by subtracting 1 from all three sections. Subtract it from the left, the middle, and the right. Okay, and I'll bring down what I have remaining. -13 minus 1 gives me -14. I'll bring down my inequality symbol. In the middle, ones cancel out, and I'm left with just 7x. I'll bring down my other inequality symbol, and 50 minus 1 is 49. Okay, now remember, I'm still isolating my variable. So that means now I need to get rid of the 7. And I'll do that by dividing all three sections by 7. So this is negative 14 divided by 7, which is negative 2. Bring down my inequality symbol. 7's cancel out. Bring down my x. Bring down my inequality symbol. 49 divided by 7 is 7. So my solution, I have x's that are less than or equal to 7 and x's that are greater than or equal to negative 2. When I get ready to draw my number line, I know I have to put the numbers negative 2 and 7, and I know I have to circle them. I also know that I have to enclose them because it says less than or equal to, less than or equal to, okay? Now, x's that are less than 7 to the left, x's that are greater than or equal to negative 2 will be to the right. So this is what my graph would look like. Once again, my solution is all real numbers between negative 2 and 7, including negative 2 and 7. Now what I want you to do, I want you to pause the video. I want you to work the remaining two problems in example 2, then restart your video so you can check your answers to make sure that you have them correct. Okay, if you've restarted the video, that means that you completed the other two problems on your own and you're ready to check your answers. So let's go ahead and take a look. So the next one, we have 37 less than negative 6x plus 7 less than or equal to 55. You know that you have this inequality and excuse me, and your goal is to isolate the variable x. So we're just using the same transformations that we previously used when we were solving inequalities or equations. I know you have to get rid of the 7 first, so I'm pretty sure that you subtract 7 from all three sides. Left you with on the left 30. Bring down the inequality symbol. In the middle, negative 6x. Bring down the inequality symbol. And 55 minus 7 is 48. Then you had to divide all three sections by negative 6. 30 divided by negative 6 is negative 5. You divided by a negative, so you had to reverse your symbol. Negative 6 is canceled out. Bring down the x. Bring down your inequality symbol again, remembering that you divided by a negative, so you have to reverse it. And then 48 divided by negative 6 is negative 8. So what you have is negative 5 greater than or equal to x, greater than or equal to negative 8. When you drew the graph, you had negative 8 here, negative 5 here. Remember to put your numbers in order as they would appear on the number line. The numbers had to be shaded in because they are included in the solution. We needed x's that were less than or equal to negative 5, which are to the left. And we needed x's that are greater than or equal to, over here, we need x's that are greater than or equal to negative 8. So that's what we would have here. So that's my graph. My interval notation would be this. So this entire thing is what my solution would look like. Okay? If you made a mistake, make sure that you correct it so that when you're working by yourself, you have something to refer back to. Okay, and then the last one. Same old, same old. My goal is to isolate my variable x in the center. So I know I have to get rid of this minus 3, so I would plus 3 to all three sections. Negative 2 plus 3, excuse me, negative 1 plus 3 is a positive 2. Bring down my inequality symbol. Bring down 2x in the middle. Bring down my other inequality symbol. And then I have 1 plus 3, which is 4, dividing by a positive 2. 2 divided by 2 is 1. Bring down my symbol. X in the middle remaining. Bring down the other symbol. And then 4 divided by 2 is 2. Okay? 1 is included in the solution, so make sure that you shade it in. 2 is not included. I want x's on this side. This is saying x is greater than 1. Anything greater than 1 to the left. This side says x is less than 2. Anything less than 2 would be to the left. Did I say that this was to the right? Let me go back. I don't know if I said that. Let me make sure I said that correct. This is saying I want x's that are greater than 1. Anything greater than 1 is to the right. I hope that's what I said. Okay? So that's the correct graph. And this would be the notation that goes along with it. So this is your correct answer. Okay, let's look at example 3 together. On example 3, we have 4 problems. We'll do 2 together, and you'll work 2 on your own. Now, for example 3, these are OR inequalities. Or we did example working the graphs together, so you know what the graph is going to look like. Let's go ahead and solve a few of these. Now, one thing that I want you to be careful about, this says 7x minus 12 greater than or equal to 16, or 21x plus 12 less than or equal to 0. You have to solve both. I had students before, they felt like since it said or, they got to choose which inequality that they solve. No, you have to solve both of them. They go together. Okay? So all you need to do is just solve each one. Solve them one at a time. They're just two simple inequalities put together. We're just going to graph them on the same graph. So the first one, I have 7x minus 12 greater than or equal to 16. So I know my goal is always to isolate my variable, so I need to get this x by itself. So I know that means I need to get rid of this minus 12. And in order to do that, I'll add 12 to both sides of my inequality. Okay, I'm just doing this first one by itself. So that leaves me with 7x. 12's cancel out, bring down my greater than or equal to symbol, and 16 plus 12 is 28. Now I'll divide both sides by 7. That leaves me with x greater than or equal to 28. 28 over 7 is simply 4. Okay? Now I'll come back and I'll solve this other one. I have 21x plus 12 less than or equal to 0. Start off by subtracting 12 from both sides. That leaves me with 21x. 12's cancel out. Less than or equal to negative 12. Then I'll divide both sides by 21. 21's cancel out. Bring down my inequality symbol. And negative 12 divided by 21, when I reduce that, it will be negative 4 over 7. Okay? So now when I get ready to graph, I just simply graph them on the same number line. I just simply graph them on the same number line. Remember to put your numbers in order as they would appear on the number line. I see that they both have to be shaded in because they're included in the solution. This first one says x's, I want all x's that are greater than or equal to negative 4. Anything greater than negative 4 is to the right on the number line. And the second one says I want x's less than or equal to negative 4 over 7, negative 4/7. And anything that is less than or equal to that, less than that, would be to the left. So that's what my graph would look like. This was what my notation would look like, and the graph. Okay, for our next inequality, we have negative 4 minus 3x less than or equal to negative 22, or Negative 8 minus 4x greater than 40. Okay, so we just have to solve both. Just do them one at a time. My first one, I have to get rid of this negative 4 first, so I'll add 4 to both sides of the inequality. That leaves me with negative 3x less than or equal to negative 18. I'll divide both sides by negative 3. Remember, when you divide by a negative, you must reverse that symbol. Okay, so I'm left with x greater than or equal to 6. For the other side, I'm going to do the same process. I have to get rid of this negative 8 first, so I'll add 8 to both sides of the inequality. That leaves me with negative 4x greater than 48. I'll divide by negative 4. Reverse the symbol because I divided by a negative. And 48 divided by negative 4 is negative 12. Okay, now I'm ready to draw the graph. I have my intervals. I have negative, x greater than or equal to 6 and x less than negative 12. I'll put my numbers on my number line, making sure that they are in order as they would appear on the number line. The negative 12 is not included in the answer, so I don't need to shade it in. The negative 6 is, so I'll shade that in. For this one, this first one here, I want x's that are greater than 6. That's everything to the right of 6. Did I say negative 6? If I did, I'm sorry. I want x's that are greater than or equal to positive 6. That's everything to the right of 6. And on the next one, where I have x less than negative 12, everything less than negative 12 will be to the left. Okay, so that's my graph. And once again, my interval was x greater than or equal to 6 or x less than negative 12. Now, what I want you to do, I want you to pause the video. I want you to work the remaining two problems. In example 3, once you are finished, please restart the video and check your answers. Alright, once again, if you've restarted the video, you're ready to check your answers. So let's check out these last two on example 3. Okay, we're still solving and graphing inequalities, and we're still working with the OR inequalities. Okay, these were fairly simple. The first one I have 9x minus 1 less than negative 17, and the other one I have 7x minus 12 greater than 9. So you just solve them both, graph them on the same number line. That's your solution. So I know I need to get rid of the minus 1 first, so I'll add 1. So that leaves me with 9x less than, negative 16. I'll divide both sides by 9. I'm dividing by a positive, therefore I do not need to reverse my symbol. So this would be a negative 16 over 9. Now you can leave it like that, or maybe your teacher is instructing you to change that to a mixed number. So this would be a negative 1 and 7 over 9. Okay, then you just come back and do the other one. I'm going to have to rewrite this one. Let me divide it up. I'm going to rewrite this one. Give myself a little bit more space. Okay, I have to get rid of the minus 12 first, so I'll do it by adding 12. It's a fairly simple process. It's just the same steps over and over and over and over. So I have a 9 plus 12. That gives me 21. I'll divide both sides by 7. Divide by that coefficient. Cancels out. 21 divided by 7 is 3. Okay, so now the only thing that I'm lacking is my graph. So here I would have a negative 16. I'm going to use the fraction. 16 over 9. And over here I would have 3. Those answers are not included in the solution, therefore I don't need to shade in my circle. On the left, I have x less than negative 16 over 9, everything less than to the left. On the other side, I have x greater than 3, everything greater than 3 is to the right. That's my final answer. Once again, if you've made a mistake, please make your correction. And then on the last one, I have 6x minus 1 greater than or equal to 11, or x plus 7 less than or equal to 3. I'll add the 1 to both sides, leaving me with 6x greater than or equal to 12. Divide by 6. Leaves me with x greater than or equal to 2. For the other side, I'm going to rewrite it again, giving myself just a little bit more space. Now this one is very simple. All I need to do is to subtract this 7 from both sides, leaving me with x less than or equal to negative 4. Okay? So my interval that I have, let me put it together, make it look a little bit more, little neater. I have x greater than or equal to 2, or x less than or equal to negative 4. So I'll draw my number line. Negative 4 is included in the solution, so I need to shade. And 2 is also included, so I need to shade. X is greater than 2, or to the right of 2 on the number line. And x is less than negative 4, or to the left of negative 4 on the number line. And this would be my final answer. My box is a little messy, but that's okay.